If you recall from the last lecture series before spring break, we learned about coronal mass ejections or CMEs and how they send high energy gases earthwards. These energy particles sent towards Earth are mostly deflected by Earth's magnetic field, but some of the particles may damage satellites, power grids, and more. Phenomena similar to coronal mass ejections are solar flares, as they both involve gigantic explosions of energy. Sometimes solar flares are accompanied by CMEs. Today, I'm going to talk about how solar flares occur, what the effects of solar flares are, and the future relationship between Earth and solar flares. So first off, what is a solar flare? A solar flare is a sudden and intense variation in brightness, or a flash of light, on the surface of the sun. Solar flares occur when magnetic energy is built up in the solar atmosphere and is suddenly released. There are large magnetic loops called prominences on the sun's surface, and when they touch, they actually short-circuit each other, which sets off these massive energy releases. Solar flares occur in active regions around sunspots. The energy released from a solar flare contains high energy photons and particles, and as they are released, they are heated and accelerated into the solar atmosphere. To put it into perspective, the energy released from the solar flares can reach levels of equivalent to millions of hydrogen bombs exploding at the same time. Like hurricanes or tornadoes, solar flares have classifications. Solar flares are classified according to the peak flux near Earth, and this is measured by XRS instrument on the GOES-15 satellite. Here's the table of the classes, with A being the lightest and X being the most powerful. These classes can range from 1 to 9, such as A1 to A9, except X, which can reach much higher numbers. The most powerful solar flare ever recorded was an X45 class solar flare on November 4, 2005. Fortunately, this solar flare was not towards Earth, otherwise it would have taken out the entire global satellite network. This would have caused complete havoc, as it would have fried telecommunications, banking, military surveillance satellites, and much more. By much more, I mean the human health consequences from solar flare classes of X28 and up. Here's an image of what solar flares can actually harm if they are powerful enough. So how can solar flares affect human health? Well, solar flares can affect the central nervous system, brain activity, and psychophysiological behavior in human beings. This means it can affect the moods of human beings and cause headaches, since this high solar activity can desynchronize us with our biological clocks. Also, the electromagnetic activity affects the pineal gland in the brain, which releases melatonin, which is produced to help us sleep. Solar flares also have an effect on Earth, since intense solar activity can cause earthquakes, volcanic eruptions, hurricanes, and tornadoes to occur. For example, one of the most solar active years was 2005, which resulted in Hurricane Katrina, Hurricane Rita, Hurricane Stan, Hurricane Wilma, and several other tropical storms. Not only that, but it was a hot and dry year, which created large grass fires and tornadoes towards the end of the year, which is unseasonable. So how often do solar flares occur? Solar flares typically occur more often during the solar maximum. The solar maximum is the max period in the 11-year solar cycle in the sun's activity. This means there is a change in the number of sunspots, which in result means the number of solar flares. During the solar maximum, there can be as many as 100 solar flares a week. However, like previously mentioned, not all solar flares are directed towards Earth and not always powerful. Since the Earth's magnetic field prevents many of the sun's radiation and particles to come to Earth's surface, we are not severely harmed. However, if the energy and protons released from solar flares could travel to the Earth at the speed of light, or reach us within 8 minutes, we would all be obliterated. This, however, would break Einstein's rule that matter cannot travel at the speed of light, so for now, we do not have to worry about our lives being lost to solar flares. Thank you for watching this presentation. I hope you learned more about solar flares and now have an understanding about the effects they have on Earth.